Now let's see this remove duplicates from sorted array problem. I mean, this is an easy category problem. From given example, you can understand that for given array, if there are duplicate or repeating numbers, we just have to remove them. And at the end, return the size of the array after removing the duplicate. So I mean, if you try to think in that way, you don't have to return the actual array at the end, which is a big relief, because for that you might have to code something else. But now, given that you just have to return the size of that after removing the duplicate elements. So are you able to recall a collection framework for this? I mean, if we are trying to solve it in brute force, we can use set, right? Set only contains unique elements, so why can't we do that? We can use set and we can return the length of the set at the end. And this brute force approach is also giving you big O and time complexity, but it will take some extra space that we'll try to reduce in the optimal approach. But let's see this brute force approach. So I'm taking the same example. I'm taking the set, and also I'm taking linked hash set, so that in some point if you want to return the array also, you can do that. I mean, this is a follow-up question can asked by interviewer. Now I'm just adding, like I'm just visiting each numbers which is given. I'm just adding to the set, and set will take care of the duplicates, and then we can calculate actually the length of the set at the end. But before that, whatever element that we have, we can put back to the nums array. I mean, which is not much required, but you can do that. For this case, we just have to return the size of set, and that will be your answer. Just try to run this. It will giving you 5. I think that is what required. I've taken this example and this is giving me 5. That's okay. Now we can optimize this by not using this set and try to think something else. So if you try to think, we can take 2 pointers here, right? Because ultimately we are visiting each node, and why not we just keep a pointer steady and check for others. If they are repeating, we'll remove. And there is a pre-given condition that it is already sorted, so which make this problem easier. If that is not the case, then first we have to sort that, and then we can apply the logic, or later you will find out we'll using some other Java techniques to solve this problem. But for this one, as we are learning 2 pointers approach, we can do this. So let's back to the code. Let's try to take 2 pointers. First is slow pointer, another is fast pointer. Till now we are taking 2 pointers at the extreme end, but this one is different. We can take like first pointer at the beginning, that slow pointer keep track of non-repeating numbers, and we can have a fast pointer like this, which start with the next element and just iterate over the array, and this will us increment every time, as this is a for loop, right? And we are trying to solve it in linear way or big O and complexity without using extra space. So every time we visit, we can compare, or we can decide when I should be incremented. So whenever ith number and the jth number is not equal, I should be incremented, because I is keep tracking of the non-repeating numbers. And then we can assign the ith element to the jth number. So I think you can now imagine, right? I is just keep track of and keep noting down unique element. J is moving whenever it got some non-repeating character which is not matching with I. J is just assigning that to I. In this way, at the end you will get the ith position on that point where it is just containing non-repeating character. So that what we are going to do, we are just returning the ith position. That is it. We don't need anything else fancy. So let's try to run this in Leetcode. Let's try to just run this test cases which is passed. Let's try to submit this. It is beating 79% of the programmers, but you got the idea, right? How a simple 2 pointer approach can bring the change. Alright guys, see you in the next one.